Hello, today we are going to start up chapter 4.1. Today we're going to look at transforming data to achieve linearity. So we're going to use this program called Fathom that's going to help us investigate these nonlinear situations. So if I take some data on the age and life insurance premium, if I drag down age and now I look at premium, hopefully you can look at this data and say, this doesn't look too linear. And if we want to prove that, we can draw a least squares regression line, and in there, we can make a residual plot underneath. If you look at the residual plot, there's definitely a pattern in that residual plot, so this data does not fit a linear graph. So now there's some things that we can do, and we'll want to linearize this, and there's many different ways to linearize it, but typically in AP Stats, we're going to be dealing with logs. So we can take the log of premium and put it on the y-axis and look at that data. That looks really linear. The residual plot looks like it's pretty scattered, so there's no good pattern here. So that'll tell us that the original data is relatively linear. Now we could also take the log of age and throw it down here, but you can see that's not a terrible pattern up here, but you can see the residual plot shows a little bit of a curve. So the best one out of the three, oops, is there. Um, so this this program gives us the equation log premium equals 0.037 times age. Now we can also solve that like we did yesterday and write it as a nice exponential equation. Now we can also take another graph. Let's say if I look at mammals. If I'm looking at certain mammals and I can take their body weight and their brain weight. Here we go. Now this data doesn't look very good at all. You can see that there's a lot of data here, some data here. So that doesn't look all that linear. So, but if I take the log of body and put it there, it's still not linear. So if I take the log of brain, that looks like a pretty linear graph. Now to check linearity, what we'll do is we'll want to add a least squares regression line, and then from there add a residual plot underneath it. Notice how this residual plot's really scattered, and so it looks like it's a pretty good description. It tells us that the original data is fairly linear. All right, so now we're going to use this and try to figure out how to do this with our calculator. I have to bring this up. So our first problem is the radius and price of pizzas are different from various pizzerias that are recorded below. And so what we're going to do is pause the video and put that into your calculator. Now we want to first start out, you have that in L1 and L2. Let's do a least squares regression. So I have that in L1, L2. We're going to quit out of there, and we're going to do a least squares regression. So stat, go over to calc, linreg is number 4, L1, comma L2. Now here is my least squares regression. So we can say this is y hat is equal to 3.2x plus negative 9.5. So I'll just say minus 9.513 and so on. Now if we look at this original data, we can plot it using our stat plot. I'll turn it on. And we have L1, L2. So I'm just going to zoom in. And this is what the data looks like. It doesn't look incredibly linear, but we'll still continue. Now, the next thing tells us to sketch the residual plot. So not the original data, but the residual. since I've already done a linear regression, now I just have to go into my stat plot and my Y list I can just turn to resid, or the residual list. So second stat, my number 7 is residual. So if I hit zoom 9, that shows the residual plot. Now, if you're on you don't have the luxury of doing this that I have, but you can figure out each point and plot them along the axis. So is this a good model? Looking at the residual plot, you'd say no, and you'd say something about how there's a curve in the residual plot. All right, so then we just continue. And on the next page, it says, now let's put log of price in our L4 and then plot that against the radii. So I'm going to come in here, hit stat, I'm going to edit. Now I'm going to go all the way over to L4 and hit log of L2. So I'm going to log all of these values. All right, so now I want to look at this linear regression of L1 and L4. So it's my x values and the log of my y's. And that pulls something over here. So I could say the log of my y hat is going to equal 0.14788. I guess I could have probably just said 0.15 x plus negative, so I'll say minus 0.028, so 0.029. So that's my equation. For x is my radius, y is my price. So if we want to transfer this into an exponential equation, this is what we did yesterday. We'll take 10 to each power. And so we have y hat is equal. Now, you can separate this up first, and this would be times 10 to the negative 0.029, which 10 to the negative 0.029, you can take out the calculator, 10 to the negative 0.029 will get us to 0.935. So I like to put that out in front, 0.935 times 10 to the 1.5 10 to the 1.5, 31.6. So then that's times 31.6, and that x still stays up in the exponent. So that's our equation, 9.35 times 31.6 to the x power. Now we can also use, since we have the original data, we can use the exponential regression by hitting stat, over to calc. Exponential regression is near the bottom. It's that 0 on mine. So exponential regression. And we're going to want to use L1, comma L2. We use the original data for the exponential regression. So here is our data. Now I just noticed that I did make a mistake back here. This is 0.15, and for some reason I turned that into 1.5. So those would be 1.5s. And this would be, if you take 10 to the 0.15, that would be 1.41. Now, I could tell that was a mistake because my exponential regression should equal this. Y hat would be equal to a 0.936 times 1.41 to the x power. All right, so hopefully that mistake didn't screw you up too much. Now we need to find the residual plot for this. So we've already done a linear regression of L1 L4. And after we do this regression, it puts it all in the resid, so we can go second stat, L1 resid. We're already good to go. So now we have a graph that looks like this. Now I think this clearly has a nice curve to it. So I would say this is not a good model. It has a curve in residual plot. All right, so let's do this again. Now let's look at logging both sides of the equation. So now I'm going to go into my stat plot. And I'm going to edit this. My L3 now I'm going to turn to log of L1. And now I'm going to do a linear regression with L3 and L4. So we're doing a linear regression with just our logs. All right, now we have an equation like this. So this is going to be log of y hat is going to equal to 2 times the log of my x minus 0.639. Now if I transform this, 10 to the log of y hat is equal to 10 to the 2 times the log of x minus 0.639. So I have y hat is going to equal, equal, now 10 squared, 10 to the 2 times log of x. I'll separate this out first, so it's 10 to the negative 0.639. Now first, what we want to do is 10 to the log of x. That 10 and the log will cancel out. So that will just leave x down there, and the 2 is still left in the exponent. So now if we want to find this coefficient out in front, we take 10 to the negative 0.639, and we get 0.23 about. Now we could go into our calculator and do a power regression. Of L1 and L2, our original data, and see what this looks like. See how it's the same data that's here? So it would be, you could still get the equation. I guess I don't even need to write it again. 0.23 x squared. Now, you might be asking, why do you go through all these steps if you can just do a power regression? Well, not every question has the data already lined up. Sometimes they have just linearized it. So AP could give you a question like this and then tell you to convert it to an exponential equation or a power equation. All right, so now if we want to sketch the residual plot, we could make sure a linear regression is our last one we did of L3, L4. And now our stat plot, I believe, is still at L1 resid. We could do L3 resid. It actually will give you the same answer. And it looks like this, which isn't perfect, but it is a little bit more scattered than our other two graphs. So is this a good model? Well, it's better than the rest. It is the best so far, because this is pretty scattered compared to the other ones. All right. Now here are two problems that I want you to try on your own and see how far you get with them. Uh, there's 4 and 5. All right, once you're done with these problems on your worksheet, then I want you to play this video again, and I'm going to show you the last two slides with the answers. All right, here's number 4. This is the original scatter plot. This is the original residual plot. So hopefully from these you see that the original data is not linear. So then the best plot I got was when we logged the y's only, and then you can transform that into an exponential function. Another one we can do for 5, the original data is definitely not linear. The residual plot has a curve in it. So the linear regression, this had a log here. Should be the log of distance, and then it goes down. All right, hopefully that helps you out to get started on your homework. Good luck.